Welcome to Dave's Think Tank. Here at the Think Tank, we get all kinds, and this week was no exception. A couple of days ago, a couple of flat earthers contacted us. If you're not aware, there are people living today who, with full access to the collective knowledge of the entire human race at their fingertips, choose to believe that the earth is flat. Some of them even have high school degrees. But here at the Think Tank, we don't judge. We're here to help anyone who has a problem. So, these flat earthers had a request. They wanted me to come up with irrefutable proof that the earth is indeed flat. My first response was to tell them, the earth is actually round, and so what you're asking is not actually possible. But impossible is what the think tank is all about. And so, 5 minutes later and $5 richer, here is the solution I gave them. Irrefutable proof that the earth is flat. Hi, and welcome to Dave's Think Tank. In order to prove the earth is indeed flat, we first need to know a few things about the universe. Like, the universe in which we live is three-dimensional. This means using three numbers and a starting point, we can locate anything in the universe. Let's set the starting point to be the center of the earth. Then suppose we want to find the moon. Well, we can go 200,000 miles to the right, we can take a hard left and 100,000 miles forward, then 90,000 miles straight up, and there it is. We can locate anything in the universe this way. Except this isn't the natural way of locating things. If you want to see the moon, you usually say, "Hey buddy, look at the moon over there." And he'll turn in the direction you're pointing and ask, "Where?" And you'll say, "Up there." This is, in fact, the way scientists locate things on the surface of the earth. You may have heard of latitude and longitude. This was invented by scientists imagining themselves at the center of the round earth, because that's what they believe, and pointing out stuff to their buddies. "Hey buddy, there's the Great Pyramid." "Where?" "Up there." Now, if you want to locate anything in the universe, you just add a distance to this. For anything on the earth, the distance is 3,950 miles from the center of the earth. Now suppose the moon is directly over San Francisco. We can say it's 240,000 miles that way. We can locate anything in the universe now using this coordinate system. Another way to locate anything on Earth, instead of looking up and down 90 degrees, we could use a measurement of distance from the North Pole. Let's call this measurement delta, which should impress the scientists. Then we can locate the Great Pyramid or anything on Earth or anything in the universe using our new dimension delta. So how does any of this prove the flat Earth, Dave? I can hear you asking. So far you're just assuming a round Earth in a three-dimensional universe. But dimensions are tricky things. They can look like one thing but actually be something completely different. We all know that there's a fourth dimension called time, but we perceive this dimension very differently to the other three. No one can point and say, "Hey, look, buddy, the future." There are also scholarly articles written by scientists who believe the universe may actually be two-dimensional, and the third dimension is in fact an illusion created as a hologram. Other scientists tell us that the universe has at least 10 dimensions, but 7 of them are folded and wrapped so we can't even see them. So what if what we perceive as a round Earth with a universe around it is actually a spatial dimension wrapped in a circle around the center of the Earth? If this is true, how can we unwrap it and see the universe as it truly exists? We've already done the hard work on this. Remember, we can identify any point in the universe using our measurements r, theta, and delta. But what if delta is this dimension that has been wrapped around us? Instead of following this measurement around the globe, let's straighten it out. So what does the surface of the Earth look like now? This may look familiar to you. It's the map of the Earth that most flat earthers subscribe to. But if straightening out this dimension makes the Earth look like this, what does it do to the rest of the universe? We can easily see two of our dimensions, theta and delta, in this map. We just stand at the North Pole, which, by the way, is a lot easier than standing at the center of the Earth. we turn theta degrees, we walk delta miles, and we can get to anywhere on the planet. Then r, which was a measurement of distance above the round Earth, is now a measurement directly above the flat Earth. But this means that everything in the universe is directly above some point on the flat Earth. The entire universe is, in fact, a tube with 3,000 miles of dirt and rock at the bottom, the surface of the Earth on top of that, another about 100 miles of atmosphere on top of that, and everything else in the universe above that. Go out 240,000 miles, and there's the moon. Another 93 million miles, and there's the sun. All the planets are out there, other galaxies, everything. Want to know how big Jupiter, the largest planet, is? It doesn't look very big, and it turns out it's not. It has to be smaller than the Earth, since it fits in an Earth-sized tube. Same for the sun and all the planets. All the stars are just tiny points of light, like you always thought. But Dave, does this actually prove the Earth is flat? Aren't scientists going to ask questions like, what keeps the moon and the sun up there? Why don't they fall down to Earth? And here's where you get to kung fu their own logic back at them, because the answer is simply gravity. The same word they throw at you without explanation has just as much explanatory power in the flat Earth universe, because just as we can map any point in their universe to ours, we can also map any force from their universe to ours. The force of gravity, which keeps things moving in circles around their globe Earth, keeps things balanced and stable high above your flat Earth. In fact, doesn't it make more sense to say that things stay in place where they are, rather than proposing some mysterious, unexplained force that draws things together from huge distances? They then might ask, why does light from the sun light up only half the planet, when it's almost directly overhead every point on your flat Earth? To which you can shake your head condescendingly and explain, light travels in straight lines, but the universe is folded, and so straight lines to us are not really straight. As the angle of light coming toward the Earth becomes larger, the angle through the folds of the universe becomes greater, and the beam of light is deflected away from the Earth. The same principle causes ships at sea to seem to disappear over the horizon. It's simply the bending of light toward the Earth, then away from it, as it follows the folds of the universe. So do you fall off the edge of the flat Earth? No. As you cross over the South Pole, which we can see here stretched out around the edge of the flat Earth, the dimension curves back on itself, and you end up on the opposite side of the flat Earth. And also, if you dig to the bottom of the flat Earth, you don't fall out of the bottom, but will find yourself digging upward to the opposite side of the planet, just as you would in the round Earth. And what about photos of the Earth from space? They certainly look round. Flat Earthers usually have to claim that these are fake, even though it's pretty obvious they aren't. But a round Earth is exactly what you would expect to see in a flat Earth universe as I've described. Light from the Earth will follow the warped path of the twisted dimension, giving the impression of a round Earth. In fact, everything in the globe universe corresponds to something in the flat universe. After giving them this explanation, I guarantee you that any honest scientist is going to have to admit it is impossible to tell which universe you are in, their globe Earth universe or your flat Earth universe. To anyone living in one of these universes, there is no test you can perform to tell which one it is, even if you are a smarty-pants scientist. The best you can do is use the one that makes the most sense to you in your day-to-day life. And for the vast majority of people on the surface of the Earth, the flat Earth model makes a lot more sense to use in your daily Earth-bound business. Finding a route across town to your kid's soccer game that hopefully goes past the dry cleaners is a lot easier with a flat Earth, rather than trying to figure out using a model based on spinning balls traveling in elaborate spirals at astronomical speeds. One final note to flat Earthers. Some of you may be disappointed that my flat Earth model doesn't predict a sun and moon that are close to the Earth. You wanted the moon to be 2,000 miles above us, the sun to be a few miles further, and all the stars to form a dome a few hundred feet above that. Well, go ahead and believe that if you want to, because there's a formula for that as well. Indistinguishable from our previous flat Earth, indistinguishable from the globe Earth, a universe custom made just for you.